Hi, in section 3.4, we want to uh, get familiar with this another set of formulas in trigonometry, which is called product to sum and sum to product formulas or identities. These sets of formula helps us to um, change the product to the sum, or if we have a sum, addition or subtraction between the two trig function, change them to multiplication. You can see on these slides the product to sum formulas. If we have two sine, the sine of angle alpha, which is multiplying by the sine of angle beta, but you need to change them to sum or difference of two other trigonometric function, you can use this formula. And all of these formulas are coming by just adding or subtracting the formulas by using the add or the sum and difference between the two angles, which we learned in previous sections. So we learn about the cosine of alpha minus beta, or the cosine of alpha plus beta. So we know the formulas for them. So now if we add the cosine of alpha minus beta, we actually with cosine of alpha plus beta and then divide the result by 2, we get only cosine of alpha times cosine of beta. But if we subtract cosine of alpha by cosine of alpha minus beta by cosine of alpha plus beta and then divide the result by 2, we get the sine of alpha times sine of beta. Alpha and beta are our angles. If we add two sines, we get sine of first angle times the cosine of the second angle. But if we subtract the sine of sum and difference of two angles and then divide the result by 2, we get the cosine of first angle times the sine of second angle. The only difference that the third one and the fourth one have is just this, that on the third one we have the sine of first angle times the cosine of second angle. So we have to put the first angle alpha first and then beta, alpha and then beta. It may not change anything when we are adding, but for sure there is a difference when we are subtracting, which angles it comes first. And if we subtract the two sine, when the alpha is the first angle and the beta is the second angle, we get the cosine of the first angle times the sine of the second angle. Now let's look at an example. I have a product and I want to show this product as a sum or difference. The product is the product of two sine, the sine of 5x and times sine of 2x. And in this problem, 2x and 5x are our angles. And we learn about the sine of two angles, which is this formula. When we have the sine of an angle multiplying by the sine of another angle, we need to use this formula. So I'm going to use the formula. So write the formula first. And we need to identify what is alpha, what is beta. And in this example, the alpha is 5x and the beta is 2x. So we replace the alpha by 5x, replace the beta by 2x. So we get 5x minus 2x and 5x plus 2x. And 5x minus 2x is just 3x. 5x plus 2x is 7x. And since cosine of 3x and the cosine of 7x are not like terms because the angles are not the same, so we cannot add or subtract them. We just have to leave it as is. Next example. We want to show this product as a sum or difference. This time we have a product of two cosine. The cosine of angle 7x, which is the alpha, times the cosine of angle x, which is my beta. So this time we need to write the formula, which is for cosine of alpha times cosine of beta. Alpha is 7x, beta is x, and 7x minus x is 6x, 7x plus x is 8x. Again, cosine of 6x and the cosine of 8x are not like terms because the angles are not the same. So that's my final answer. The answer is half of cosine of cx plus half of cosine 8x. In this example, we have this product, the 2 cosine of 7x over 2 times the cosine of 3x over 2, and we want to change it to sum of two trigonometric functions. So my first angle, or angle alpha, is 7x over 2, and my second angle, or angle beta, is 3x over 2. So I'm going to write the formula first. So, and I know that the formula, the cosine of alpha times the cosine of beta is 1/2 cosine of alpha minus beta plus cosine of alpha plus beta. So we replace this formula for this part only. We have a 2 outside as well. We need to keep that 2. So we keep the 2 first, and we replace this whole formula for that part of the cosines. So 1/2 cosine of alpha minus beta plus cosine of alpha plus beta. We can cancel the 2 and 1/2, so there's no more number in front of the parentheses, so that means we can easily drop the parentheses. I only need to add or subtract the angles inside these parentheses. What is 7x minus 3x, which is 4x, and 4x divided by 2 is 2x. 7x plus 3x, which is 10x, and 10x divided by 2 is 5x. And that's the final answer. And cosine of 2x, cosine of 5x are not like terms, so we cannot add them. Okay. We want to express this following product as a sum containing only sine or cosine and no product. Okay, so we have one sine, one cosine. That's angle alpha, and that's angle beta. So we need to write the formula for one sine and one cosine. The sine of angle alpha times the cosine of angle beta, which the formula is on the screen right now. And we only need to replace the angles for alpha and beta. So if you replace the answers, the angles for alpha and beta, we have alpha plus beta, which is 4 theta plus 2 theta plus sine of 4 theta minus 2 theta. 4 theta plus 2 theta is 6 theta. And 4 theta minus 2 theta, which is 2 theta. This whole thing must be multiplied by 1/2. You can just keep the 1/2 out of the parenthesis, or if you need to distribute, you can distribute the 1/2 by each of the signs. So we can rewrite it as the 1/2 of sine of 6 theta plus 1/2 of sine of 2 theta. But remember, this 1/2 is a number. That's a number and cannot be multiplied by the angles. So you cannot multiply it by 6 theta or 2 theta. You have to keep it out of the sign. And that is the final answer. These sets of formula gives us the ability to change the sum and difference to product. If we have a sine of 2, the sum of sine of 2 angles, I can, by using this formula, I can rewrite it as a product of 2 trig function. If you have a difference of 2 sine function, we can use this one to rewrite it as a product of 2 function. Adding 2 cosines, subtracting 2 cosines, they all have a formula for changing the sum or difference to product. And these formulas also can help us to simplify expression, because when we want to simplify expression, we need to have everything based, just multiplication or division. Otherwise, if we have add or subtract, we are not able to simplify. And these formulas let us to change the sum to product, and then if there is anything, we simplify those. Let's look at an example. We have a sum of sine of 7x plus sine of 3x, and we want to change it to product. So the formula for this adding two sine is the first formula. So we need to use this formula and then change the sum to the product. And in this case, remember, this alpha is your first angle, beta is your second angle, but when you're changing to the product, you need to add the two angles and then divide by 2. So we do the same here. You write the formula and replace the alpha by 7x and replace the beta by 3x. So the 7x plus 3x divide by 2. 7x plus 3x is 10x. 10x divided by 2 is 5x. Cosine of 7x minus 3x, which is 4x, and 4x divided by 2 is 2x. And that is the final answer. And by using the formula, we easily change these to the product. So these two expressions are exactly equal to each other. So if you're solving any problem, you are verifying any identity, simplifying an expression, and you have a sum of two signs, and you can't do anything because they are not like them, that you can add them, and you can even simplify because there is an addition between the two signs. So you can easily change it to the multiplication, and then if there is anything to simplify, do it, just simplify. Next example, we have a sum of two cosine. We want to change it to the product. Again, we write the formula for the cosine this time. So the cosine of alpha plus cosine of beta is the 2 cosine of alpha plus beta over 2 cosine of alpha minus beta over 2. Replace the alpha by 3x, replace the beta by 2x, and 3x plus 2x is 5x divided by 2. We cannot divide 5 by 2. We can just leave it as a 5x over 2. And if we subtract 3x minus 2x divided by 2, we get 1x over 2. Again, we just have x over 2. You can leave it as is. But remember that if you had your angles as a 3x and 2x on the first expression, now you have your new angles. And this example wants you to prove the identity. Okay. To prove or verify any identity, we always start from one side. And for sure, I'm going to start from the left side because we have more function to work with. We have more complicated on the left side. So if I start from the left side, on the left side, I have a cosine of 40 minus cosine of 2t divided by sine of 40 plus sine of 2t. When I look at this expression, I see that there is a subtraction on the numerator and denominator. And the subtraction doesn't let me to separate the functions. When you have add or subtract on the numerators or denominators, it means the whole numerator or denominator should be simplified, or you cannot separate the functions, the whole or nothing. So right now, because of the subtraction, I cannot look at the cosine of 40 but separately. I always have to look at the cosine of 40 minus cosine of 2t. And I see that in the numerator I have cosines, and in the denominators I have sines, and I cannot add or subtract them because they are not like term. I cannot simplify, I cannot cancel out. The only thing that I can do right now is that I use the sum to product formulas to change the numerator to a product. And the same for the denominator. Use the sum to product formulas to change the denominator to a product. Because if I can change everything to product on the top and the bottom, and there is no more add or subtract in between, I can easily cancel out or change it to another function. So what is the formula for the cosine of 40 minus cosine of 2t? The formula for the cosine of alpha minus the cosine of beta. So let's go back to the slides. Cosine of alpha minus cosine of beta. Negative 2 sine of alpha plus beta over 2 and sine of alpha minus beta over 2. Okay, so it's negative 2. So let me just write it. Negative 2 sine of alpha plus beta over 2 sine of alpha minus beta over 2. That's the formula. Now I'm going to replace alpha by 4t and the beta by 2t. So it's negative 2 sine of 4t plus 2t over 2 times sine of 4t minus 2t over 2. The formula for the sine, what is the formula for the sine of alpha minus sine of beta, which is 2 sine of alpha plus beta over 2 sine of alpha minus beta over 2. So we will have 2 sine, oh, that's a cosine, sorry. Sine times cosine. That's the formula. So it's 2 sine of 4t plus 2t over 2 times cosine of 4t minus 2t over 2. To simplify the angles, 4t plus 2t is 60 divided by 2 is 3t. So we have sine of 3t. 4t minus 2t is 2t divided by 2 is just t. And the denominator, 4t plus 2t is 60 divided by 2 again is 3t. 4t minus 2t, which is 2t divided by 2 is just t. And I can simplify or cancel out the 2 and 2, and I only have a negative on top. Now, when I look at this as a whole fraction, I can see that I can cancel the sine of 3t by the sine of 3t, because right now everything is just multiplication. And when you have multiplication or division, you can easily cancel. And what's left for us is just negative sine of t on top and the cosine of t for the denominator. And I know that the sine over cosine of the same angle is always tangent. Negative tangent of t, and that's my right side. And I'm done. We proved this identity. We started from the left side, used the sum to product formulas for each of the numerator and denominator. Then we canceled out this common factors, and then whatever left for us is just the exact right side of the identity.